You should be able to use your energy diagram to explain. I mean, when they give you data, they'll give you specific data or information, and they will ask you to depict it using one energy diagram. Okay, like the first calculation we did, this other one that we got minus 184. After calculating this reaction, this enthalpy change, they will ask you to represent it on what? On an energy diagram. Okay, they will ask you to represent it on an energy diagram. So to be able to represent that on an energy diagram, it's not difficult, pretty simple. So let's look at that. So that was the HCl. You were able to get minus 184 as the what? As the enthalpy change, which means the reaction is what? Exo. So if they ask you to represent this kind of reaction on an enthalpy diagram, what they are simply saying is that draw the enthalpy diagram that shows that this reaction is what? An exothermic. Exothermic. Now that you have a better understanding of exothermic reaction, that exothermic reaction, a reaction may be said to be exo, but it involves both bond breaking and what? Bond formation. The only thing is that the bond formation, the energy released when bonds are formed is more than the energy absorbed when bonds are broken. So if you look at this energy diagram now, traditionally, you will remember that for your exothermic reaction, okay, for exothermic reaction, the energy of your product is lower than what? For exo. You know that for exothermic, okay, for exothermic reaction, for exothermic reaction, the energy of product, okay, energy of product is usually higher than what? So, what am I saying? It's usually lower. Energy of product is lower. Sorry. Energy of product is lower than what? Lower than reactant. So that means generally, even if you are drawing your diagram, you know that if you started with a reactant like this, your product will be this. Then this will be your what? Your enthalpy change. So this is your exothermic. This is reactant and product. P is usually lesser than what? Than reactant for exothermic reaction. But if you look at this diagram very well, it explains the fact that even though a reaction is exothermic, if you look at this, we started from hydrogen and what? And chlorine, right? But we show that energy is what? Absorbed first to break bond. When the energy was absorbed, bonds are broken, then to form bonds, energy will be what? Released, then your product is formed. But if you look at this, the energy released from here to here, you can see, is more than what? This is more than the energy absorbed from here to here when bonds are broken. So when we find the difference will be what? From here to what? To here, which is your minus 184 joule. Okay? Minus 184 joule. So you should be able to use information given for a particular reaction to draw the enthalpy change. So basically what you are drawing is just the temperature change. Or at best, you can draw it exactly like this and just say minus what? Minus 184 kilojoule. Because your product is lower than what? Than what? Reactant. So that will give you your mark. But ideally, before you can get to this point, okay, there is a need to absorb a little amount of energy. Okay, yes, that is where we start from. Then your reactants will now be converted to product. Okay, so if you have ever seen reactions like enthalpy diagram like this, they will draw it this way. Some will do like this, then they will draw like this. So they are simply showing you this direction going. That means you are going from absorbing to releasing. Absorbing to worry. You absorb a little, you release a lot. Can you see? So this kind of reaction is going to be one negative. Okay, so if you look at another reaction like the other one you calculated, which is ammonia and what? Breaking down of ammonia. We found out that it was plus 92 kilojoule. Plus 92 kilojoule. What that simply means that the energy absorbed, which is this, the energy absorbed, this is far, far more than the energy released when what? When the reaction is completed. So you would expect that the difference will be what? Will be a positive, which shows that this is an endothermic process. Endothermic process. So it's pretty very simple, very simple. So just to show generally, if you start from here, okay, this is your reactant. Okay, your reactant will absorb a certain amount of energy. When the bonds are broken, then energy will be released to form a product. Okay, so when your product is formed, this is product. So when the product is formed, find the difference between the two energy release, energy what absorb. Usually you just do like this. Okay, this is your difference, delta H. It's called delta H. Okay, so delta H will be positive or what, negative, depending on whether this arrow, this line goes downward or stops somewhere here. Okay, so let's look at further reinforcement. Let's look at this IG question. This is an IGCSE question. It's objective. Okay, OBJ. So quickly, who is giving us answer to this? Who is giving us answer? Who is giving us answer quickly?
Okay. Can you hear me, Mr. Ginzi?
What? So just find out, is it endo or exo? How do you identify exo? For your endo. For your endo. Yes.
This one is an endothermic reaction.
Yeah, energy of what? Reactant. That is your product, endo. So you guys can put this summary together. For your exo, okay, energy of what? Product is lower than what? Energy of reactant. So if you look at this particular reaction, this guy, this is your product. This is your reactant, okay? Your product is higher on the energy scale. That's what we mean. It's higher. While your reactant is there, which is lower, you can see. So therefore, you would expect higher minus lower is going to be delta what? H, which is going to be positive value. So it is your endothermic. So therefore, so if you look at this question now, we can say that these two can never be the answer because you have exo. So we now look at endo. The two endo says the product have more energy than the what? Than the reactant. So your answer is what? A. Do you guys see that? Do you guys get that?
Yeah, yes, Mr. Ginzi.
Okay, fantastic. Next question, quickly. Next question. Which statement about the reaction is not correct? The energy level diagram for the reaction between magnesium and hydrochloric acid is shown. Yes. Which statement about the reaction is not correct? So, who is giving us?
I think it's C.
C. Tell me, you're back, right? Oh, that's Shein, sorry.
Yeah.
Okay, C. She said the reaction is endothermic reaction. Shein, can you check this thing that I put here? Endo. What did I say? All those things, just note it down. It helps you. Endothermic reaction. Energy of your product is higher than what? Reactant.
Energy of the reactant.
So if you look at this now, look at the reaction. Sorry, my system is lagging. So the reaction that you have here, you can see. Look at your product. Your product is what? This is your product. This is your reactant. You can see that your product is lower on the scale. Can you see? This is your reactant. Yeah. So that tells you that it can never be what? This, right?
Yes.
Yes, then they say the products are at a lower energy level than the reactant. This is correct, right?
Mm-hmm.
Okay, I got what Shein is saying. Okay, Shein, I think you're right. I didn't consider this again.
You said which one is not correct?
Yes, not correct. Thank you, Shein. Yes, you can see now. I just banked that. Okay, so the reaction is what? Endothermic. Okay, which is wrong. It's not endothermic. So this is correct, right? So definitely it's the correct what answer. Okay. Yeah. Fantabulous chain. Okay, let's move on to the next one quickly. So we just look at 3 objectives, then we'll look at, let me be 2 theory questions, then I can release you guys. See another time. Okay, so the energy level diagram shows So if you have not answered any question before, you may want to just try it out. Okay, just look at the examples and summary that I gave. So this is product, this is reactor. Product is lower than reactant. So what do you think that is? Okay, if product is lower, energy of product is lower than energy of reactant. So what do you think that is? What do you think that is?
Exothermic.
Exothermic, brilliant. Tahira, right? So that means this is wrong, this is wrong. So let's now focus on these 2 guys. Okay, they are still partially correct. So we'll now look at this other side of it. So for exothermic, energy is given out to the surrounding. I think, okay, yes. Then this one say exothermic, energy is taken in. I mean, is that correct? Exothermic, is energy taken in?
No.
Energy giving out.
Oh, no, so this is wrong. Can you see? So this is, here is correct, here is correct. So this is your answer. You can see it's not difficult. Just apply the knowledge that you have left and right. Okay, apply the knowledge left and right, and you'll be fine. Okay, so if you have the fundamentals, you have the idea of the theory behind it, then in solving problems, it is your skill to be able to analyze your questions and justify why you are choosing a particular answer. That is where most students find it difficult to actually get the question right. Okay, please, you need to be solving a lot of questions now, a lot of questions. Okay, so for those of you that logged out and came in back late, maybe I'll try to edit the video and see if I can put it on the channel. You can go there and watch it or download whatever it is. Okay, for the part that you missed or even from the beginning. Okay, so let's now we have looked at that. So it's time for you guys to solve questions, maybe for the next 13 minutes or so that I have, or 15 minutes. So I have 3 questions quickly. Maybe we can do the first one together orally. Then the second one, I'll post it. It's IGCSE question. Then you guys will calculate quickly. So let's look at this one. Look at this reaction. Which type of reaction is it? Who is answering the question? Who is want to help us? Which type of reaction is this? Yes, chorus answer.
It is an exothermic reaction.
It's an exothermic reaction, okay? It's an exothermic reaction. If you look at your B, the B part, they told us it's an exothermic reaction. That means they're expecting you to say something here, something else here.
Is it like a neutralization reaction?
Brilliant. So a neutralization would be an acceptable answer for this, okay? So I need you guys to get it well. Even though it's an exam, you know they said in the second part. If in an exam, okay, they put something here, delta H, okay, minus equals to minus 100, then you can now say it's an exothermic reaction because that is something that told you that is exo because of this negative. But if they just wrote the reaction like this, you are not expected to know all the reactions in the world and know that they are endo or exo. No. When they write a reaction, yes. No, what I'm saying.
I thought you said no, like for normal exo and endo, you said exo is positive and endo is negative. But when it comes to formation of breaking bonds, you said exo is negative and endo is positive.
No, I haven't changed anything. What we're saying is that bond formation, okay, releases energy. That means it's an exothermic process. Bond breaking consumes energy, absorbs energy, needs energy, takes in energy. That means that it is an endothermic reaction. Yeah, that's what we said. Are you confused anywhere? Let me know. Okay, so what I'm saying is that, like, Alan gave us that this is an exothermic process reaction. If B was not written there, there's no way you could have you could have told me that the reaction is exo or endo, except they put the sign for you. Because at this level, you are not expected to memorize all exothermic or all endothermic reaction. Do you understand? So if somebody wants you to allude to the fact that it is endo or exo, they will either give you a background information and say when the initial temperature was taken, it was 10. When the final temperature was taken, it was 30. What type of reaction is this? Then you can now, based on that information, tell them that the reaction is what? Exo. But just looking at a reaction like this, I mean, there is nothing that informs in the question that it is exo. Do you get me? So that means they are requiring you to tell something else. So this is a neutralization reaction. And if you look at the second part of the question, they already told us the exothermic reaction. So if you put exo as your answer to the first part, like, you won't be getting the correct, the marks. Do you get my point, please? Do you get my point?
Yeah.
Okay, so they say the reaction is exothermic. What does it mean? What does it mean when the reaction is exothermic? Heat energy is what?
It's absorbed.
What?
So
An exothermic reaction releases heat.
Yes, heat energy is released.
Heat energy.
Yes, heat is what? Heat is released. Heat is released, okay? What will happen to the temperature of the solution as the chemical reacts? What will happen to the temperature?
It will increase.
Brilliant. Temperature will will increase. It's very simple. You draw the energy level diagram. Energy level diagram for this, okay? That is your sodium. Since it is exothermic what? Exothermic process. Exothermic process, you would expect that your product's energy will be lower than what? Lower than reactant. So basically, to draw the energy level diagram, okay, so we just start. So let's assume we are starting. Oh my goodness, my battery. Okay, just a few more minutes. Okay, so you would expect that if you start from here, which is your sodium hydroxide plus HCl, okay, even if it takes in a little amount of heat energy, then you have bond broken here. You have bond breaking, then it's going to release like this. Okay, then you have your what? Your sodium chloride plus what? Plus water. Okay, so the change in energy, delta what? That is this change. Okay, delta H, this change from here to here. For delta H is equal to what? Minus XXX kilojoule per mole. That's enthalpy diagram. Okay, that's enthalpy diagram. You got that right? Okay, so you guys try this. Yeah, that's this. Yeah, try this out. Okay, try it out. Just give me a minute. Try that out. Okay, any progress? Any progress?
I'm done.
Okay, where's is done?
I'm the only one here.
So what? Why are others going in and out? Okay, so what did you get, please?
So for the first one, I said we should complete the energy level diagram. So I've already done that one.
Okay, so to complete this energy level diagram, you had
The products will be
this
below.
product will be below, so that makes it exothermic. So you have your what? SF what? For gas, right? Okay,
Yes.
good. So basically, if you like, you can let it go, absorb a little, break, then it goes all the way down, which is fine. Okay, so you find your difference in energy. See, basically, this will be your delta H, and the total is negative energy given out. So this is going to be equal. So did you put the value minus 7880?
No, I didn't put the value. I just use the
Yeah.
level energy diagram.
Can you see the way I did it? Just show it because they gave you the value here. It's very important. You never can tell what the examiner might want you to include. But this is 3 marks, 3 marks. Okay.
Okay.
So you have minus 780 kilojoule. Okay. So basically now, here they say the FF bond is minus 160. So the FF bond, how many of it did you break? 2.
2.
Okay. So you broke 2 of these, which is 360 times 2.
160 times 2.
I mean, 160 times 2.
320.
That is 320. Okay.
Yeah.
Yeah, 320 plus. This is just sulfur. So to give you this. So you have 4 times what? SF, isn't it?
Yes, sir.
Okay. 4 times SF bond. That will be what? What is the value of SF?
The value of SF.
Yeah. Okay, so is the value of SF we are looking for? You're looking for the
So
value of SF.
we use the
Yes.
780
So they gave what they told us that is minus 780 is equals to what? Is equals to plus 3 what? 20 plus something. Let's say plus x. You want to know what that x is? X. Don't forget we normally add it up, right? So your x now is minus 780 minus what? 320. It should give you x. So what's your value now?
minus 1100.
Minus 1100. Okay.
Yes.
So minus 1100 equals to x. So now they told you to find the value of what? 1 SF. If 4 SF, don't forget in your calculation, 4 SF is what to be responsible for what? Minus 1100. Then 1 SF will be what?
That's minus 275.
Okay, divided by 4. So minus what?
275.
275. Okay. So that's basically enthalpy change. Okay. Yeah, I think that's where we're going to put it. Call it a day today. That's enthalpy change. So we've been able to review this. So another time we have opportunity, we'll look into another topic. But I think I may want to bring stoichiometry 2 up. Maybe one of your afternoon, what do you call it? Afternoon lessons. Yes. Make it up again.
Thank you.
Okay, you're welcome. Take good care of yourself.